In this module of oxygen delivery system, we will talk about the airflow rate. As we have seen in our previous module that the air current and the airflow inside the fermenter is very critical. So while calculating the kinetic parameters of the fermentation process, the supply of the air is very, very critical, because the supply of the air that indirectly depend upon the supply of the oxygen to the organism. If the organism is highly aerobic, and then that how effect on the growth parameters. So we have to determine that what is the flow rate. So as concern this, the airflow rate is typically reported in terms of the volume per minute, mean VVM. The first V is the volume of the air supplied to the how much volume of the, and the second V is the volume of the fermentation medium, and M is the time in minute. So if we want to calculate the flow rate in term of VVM, so the volumetric airflow rate, that how much liter of the air is supplied with the unit time to the fermenter. And then is a liquid volume, that how much is the liquid volume in liter. So in both case, liter over liter. So note that as concern the unit, so that is mostly L, and M, mean per liter, per minute, mean how much liter of the air supplied to the how much liter of the fermentation media in 1 minute. So if we want to calculate, if we just an example, if we supply a 5 liter air to the 5 liter medium in a 1 minute, then the airflow will be 5 over 5 mean 1 LLM, 1 VVM. So that's why by this way we can calculate the flow rate in fermentation medium. So in this slide you can see that FA is the flow rate of the air, A is specified to that, and V is the volume of L, mean liquid, fermentation liquid. So the ratio between FA to VL, that is basically comes in term of VVM. So by this term we can easily calculate the flow rate. So if we know the flow rate into that, and then we know the composition of that, so oxygen delivery system also having coupled with oxygen probe. So oxygen probe that sends the amount of the oxygen that is in the form of dissolved, that is meant by dissolved oxygen. So the oxygen probe sense the presence of the oxygen inside the medium. So if we want to control that dissolved oxygen in some cases, then that can be controlled by two methods, either by the increase of the flow rate or with increase the agitation. So different modern fermenters have coupled with the systems of cascade. So we can maintain the dissolved oxygen by this increasing the or decreasing of the flow rate, or by increasing or decreasing the impeller speed. So by using the cascade system, we can control the dissolved oxygen in any fermentation process. Or that is very critical. If we can maintain the dissolved oxygen, which is very complex and difficult, because as the fermentation process proceed, increase in the number of the cells, and then there is a more demand of the oxygen. So when there is a more demand, we will discuss in detail in the next chapter of aeration and agitation. Then we balance that, how much oxygen is needed to respire the 1 mole of the glucose.